join us for Heat Pumps 101. My name is Dee Dee McDowell. I'm the Sustainable Westport Residential Energy Team Leader. And as you know, tonight we are going to be learning all about heat pumps, air sourced and ground source, also known as geothermal. Our air source heat pump presenter is Matt Corona. Matt is joining us from Energize Connecticut Heat Pump Support Team. Matt is an efficiency professional focused on building decarbonization. Through his experience managing educational programs on heat pumps, weatherization, and other decarbonization measures, Matt is proud to have supported thousands of homeowners, renters, and building managers. Our ground source presenter is Brian Galzetti. Brian is the principal energy consultant for Dandelion Energy, where he leads the direct consumer division for geothermal heat pump installations across New England. Brian has been instrumental in helping homeowners transition to renewable geothermal energy, and he recently presented at the 2024 Yale Clean Energy Conference on the topic, Enhancing Geothermal. We will have a question and answer period after the presentations, but I do ask that you please submit your questions into the chat. And now I'm just going to speak briefly about Sustainable Westport. Sustainable Westport is an independent nonprofit. Our mission is to support, connect, and inspire residents, organizations, and the town to adopt sustainable changes. Sustainable Westport focuses on 5 distinct pillars that we believe are critical to building a truly sustainable community: buildings, energy, transportation, natural resources and waste management, and community engagement. And with that, I'm going to hand it over to Matt.
Thanks, Dee. I'm just going to share my screen here and we can get started. All right, we looking good? Awesome. Thanks. All right, so my name is Matt Corona. I'm with Energize Connecticut. So I'm a heat pump specialist, and I'm a part of our heat pump support team. And so today we'll be talking about heat pumps. So we'll do an overview of the technology, some benefits and considerations, and an overview on the available resources. So just quickly, like, what is Energize Connecticut? So if you're not familiar, Energize Connecticut is basically the brand for the energy efficiency programs under Eversource and United Illuminating. And so if you're a utility customer, electric customer of either of those companies in Connecticut, you have access to all of our educational resources and incentives. And so, just to be clear, we don't sell or install any of the actual equipment. My role is just as an educator. And so, it's one of the parts I like about my job. And we do, just to preface, we do one-on-one consultations with folks about heat pumps in their homes. So today we'll be talking all about the technology, and I'm sure we'll be able to answer a lot of your questions, but I'm sure people are going to have questions specific to your home. And so I'll put up a QR code later, and we can put a link in the chat to schedule a consultation. No cost with myself or someone else on our team. We can talk through your home, your goals, your priorities in detail for as much time as you need. So that's definitely a follow-up opportunity after this. Okay, so just getting into this, what are heat pumps? So at the most basic level, heat pumps are all electric heating and cooling systems. So they move heat with refrigerant and electricity, the same way that an air conditioner moves heat out of your home. A heat pump can do that. In the summer, they'll act just like an air conditioner. And in the winter, they can move heat into your home the same way. And so even when it's very cold out, there's still a lot of thermal energy in the air, and heat pumps can move that inside. So it's not really new technology, but being able to be a primary heat source in our climate is, relatively new. And in the last 5 or 10 years, the technology's gotten a lot more efficient. And so now they're very cost competitive, and we'll look more that in more detail in a little bit. So in the winter, heat pumps are moving heat into your home. Again, even when it's very cold out, still a lot of thermal energy in there. Heat pumps the refrigerant boils at like negative 50 degrees, and it varies based on the type of refrigerant, but they're able to extract heat out of, you know, 5-degree air, even colder air in our climate. We'll look more at more detail and efficiency in a second. At cold climate performance in a second. And in the summer, they act just like an air conditioner again. Uh, Another type, so we're going to talk mostly about air source heat pumps, and I'm going to leave ground source heat pumps to Brian. But a ground source heat pump is another type of heat pump, just moving heat from the ground. Air source is moving it from the air outside, ground from the ground. And I'll let Brian dig in more detail on those. So a lot of people, and I think this was even one of the questions that came in before the presentation about cold climate performance. So there are heat pumps that are designed for all different climates and for different goals. And some systems are not built for our climate to be a primary heat source in our climate. And these are kind of not like black and white categories here. There's a whole gradient of performance of heat pumps, but generally we group them as standard and cold climate heat pumps. And so you can kind of see here, both systems, these are just examples, can move 30,000 BTUs when it's 47 degrees out. And so that's what's on the sticker, right? And then, but when you look at colder temperatures, like in Connecticut, we look at performance at 5 degrees, the standard heat pump can only move, a little bit less than half of its capacity down at 5 degrees. And when it's cold is when your home needs a lot of heat. So, if your goal is to fully displace an existing heating system, or almost, do at least the vast majority of your heating, you really want to look at a cold climate heat pump. And so not all equipment's built the same or for different goals. Standard heat pumps are still used here as like supplementary heating pretty commonly. And, you might look at different types of equipment based on your goal. So if your goal was to fully displace your heating, you would want to look for a cold climate heat pump and communicate that goal to your installer so that they can size and design that equipment for that goal. So we'll get a little bit into design here. So just the basics really. And my goal here is kind of show you what's possible with heat pumps. The installer will design the system for you. So I think communicating your goals and knowing what's possible will help you get the best result. And so there's all heat pumps have an outdoor unit, and that can be paired with one or multiple indoor units, and they can be ductless, like this wall unit right here, or ducted, like if folks have central air or ductwork in their home, heat pumps can most often make use of that existing ductwork and basically swap out what you have. So homes with that ductwork, the design is usually pretty simple. You can probably use that existing ductwork. If you don't have ductwork, it's where you can get pretty. The design can get very customized for the home. There's different form factors for those ductless units. So these can go really anywhere in a home, and all three of these designs are the same thing internally. They're just different form factors, just how they look and where they might go. These can come in all different sizes. So they'd be sized for the space that they're responsible for. These can work anywhere in a home, but they particularly work well in more open spaces where you have larger, more connected rooms, and one unit can do a pretty large space all on its own. Where you have like smaller, more compact rooms, if you have unused attic or basement space, you could install a compact ducted unit that can serve like multiple small bedrooms. For example, like in a lot of colonial style homes, you might have 3 or 4 bedrooms upstairs with an attic space, and maybe you don't need to duct the whole home, but you can duct just that second floor, and do ductless on the first floor if you have a more open space down there. So there's a lot of possibilities with the designs here between the ductless and ducted options. And again, the installer will help you design a system for your home. And maybe your goal is not to go with a whole home system. Maybe you're just thinking about a single zone system. That simple design could be good to solve a comfort issue in one area of the home. But if you're doing your whole home, you might consider if you have ductwork, a ducted system, or a multi-zone system, which would again have one outdoor unit with multiple indoor units, and they could place those where it makes sense in the home. So And then, systems can get even more complex, especially with larger buildings with kind of, branch boxes and other designs that, you know, allow systems to have more indoor units. Okay, so we'll just look at a quick like 1,500 square foot floor plan here to kind of put together some of the concepts we were looking at. So, this is like sort of a ranch style floor plan here where you've got sort of this open space and then a couple bedrooms down the hallway here. And so this is a single zone design, right? You might have an outdoor unit outside, and then this is not really to scale. This this looks a little big, right? But this would be a one ductless unit, and this could solve a comfort issue over in this part of the home, perhaps, or if you're just mostly looking for cooling and to offset some of your fuel usage, this could be a good solution for that and relatively inexpensive. But it's not going to heat and cool the entire floor. It's just one unit. Um, this, on the other hand, like you know, is could be an oversized system. They can these indoor units come in different sizes, but oftentimes even for small bedrooms, putting a ductless unit in a bedroom can be oversized for it often is for small bedrooms. So sometimes this is the only solution if you don't have attic or basement space available, but a nice kind of in between design here that is will be can be tailored and designed and sized you know would be better suited for the design of the home, I should say. Could be using a ducted unit in the attic here that can serve these multiple small rooms like these bedrooms, and that they could even run a duct to the bathroom, for example, and then have the ductless over in the open spaces in this other part of the home. And so every home's different, right? And so every home might have a slightly different design, but the goal here again is just to give you an idea of what's possible. There's a lot of versatility with heat pumps. Um, and so again, that consultation, we can help you talk about your home and your layout, floor plan, all that stuff. Prep you to talk to contractors if your goal is to go with a heat pump. Okay, so now we'll talk a bit about benefits and considerations. So, why I think about a heat pump. Few main points here. You can heat and cool with one system, which is nice. This kind of simplify the mechanical in your home if you've got like separate AC and heating right now. You can, in some cases, lower your heating and cooling costs. We'll look at that in more detail in a second. And you can reduce carbon emissions by quite a bit. So heat pumps are the least carbon intensive way to heat a building, even when you account for the energy used on the grid. We can. I actually I don't have the normally I have a slide covering that in more detail, but we're gonna kind of skip tonight for for brevity. But yeah, a lot of carbon emission savings. So this is a graph showing I know one of the questions was cost of heating, and so there's a bit going on here. We're looking at temperature scale down here on the bottom, and there's this shape in the back that is using the scale here on the left. This is showing us the number of heating hours that we see in an average heating season in our climate. This is for Hartford weather data, actually. So I know down in Westport, or we're going to be a little bit warmer on average, a few degrees. So you can kind of like shift, sort of like a bell curve. So you can kind of like shift it over a few degrees. But we get most of our heating hours in this like 30 to 60 degree range, where the vast majority of our heating hours are. And we get some cold temperatures down here, but not quite as obviously not nearly as many as in that warmer band. And so what these lines are showing us is the cost of heating, creating 1 million BTUs in a home. So that's like the same amount of heat. And if you had to move that in the case of heat pumps, or burn it to create it in the case of these fuels, what would that cost you? This is using 3 years of energy costs, so it's an average, and prices bounce around and are very volatile for all fuels, including electricity. And so, if you looked at today, electric costs are actually a bit higher than the average that's depicted here on the graph. So, that's why we look at averages, because things change all the time. But what we're looking at here, I'm going to pick out oil as just an example here. Oil is doesn't the efficiency of oil doesn't change as the temperature changes because there's the same amount of heat in oil, you know, same gallon of oil, regardless of how cold it is outside. So that temperature, that cost to create that same amount of heat doesn't change when it gets colder. That's why the line is straight across versus air source heat pumps, which are, do get less efficient as it gets colder because they're moving heat from outside. So when there's less heat outside, they have to work harder. And so they use more electricity per BTU they move as it gets colder. And in the case of these three example air source heat pumps on here, you can see there is a point where oil is cheaper than those heat pumps per BTU. But I'll note that at these temperatures, it's still vast majority of the heating hours of the year. And we get, so we get relatively few hours at those temperatures where oil is less or is more efficient than this example here. So just a comparison. This is the type of math we can help people do when they're evaluating different options with their heat pumps. So we won't be able to give you a graph exactly like this, but we will help you do like analysis of estimated heating costs. But, we can use performance data from the heat pumps to do sort of this kind of modeling in a consultation. So anyway, this is an example of a cost comparison. All right, so we're going to talk a bit about efficiency first, and this is true. Any home can benefit from insulation and air sealing, but it's especially important to consider before thinking about a new heating or cooling system, because if you're able to reduce how much heating or cooling you need by weatherizing the home, that could help you in sizing a new system smaller than you might have otherwise sized it. Thinking about your goals and motivations is important before, talking to contractors. Like, what is your goal with the heat pump? You talked about maybe addressing comfort issues, or maybe your existing heating and cooling systems are at end of life. Like, those are, you'd be in a different position than someone who, doesn't need to do it, in any timely manner, or doesn't need to do the whole home, for example. And you can keep your existing heating system with a heat pump. It's sort of asterisk there. It depends, if you have a ducted system, you could sometimes keep your existing heating. It depends what your goals are and the age of the existing system. If you have radiant heating with baseboard or radiators, mechanically the heat pump is totally separate. So if there's something wrong with your existing system, you don't have to get rid of it. You can keep it. So a lot of options with heat pumps. Maintenance stuff. We've got a heat pumps 101 or a user tips guide, which has way more on this stuff. But it's basically same kind of thing with HVAC. Other types of HVAC equipment. Got to clean the air filters. The outdoor unit, like you don't want to let big leaf piles accumulate by it. Just like you would a condenser for an air conditioning system, and have it serviced annually, like other types of equipment that you spend a lot of money on and you want to live life. And we're going to go through the resources here pretty quickly because I'm running short on time. So Home Energy Solutions is a great first step for any home. This is a subsidized energy assessment through Energize CT. You can get rebates for installation. Again, this is great prep work before thinking about a new heating system. There's also an income eligible version for this too, I should say. Energize CT has rebates for heat pumps. They're mail-in rebates. They're based on the size of the equipment that you would install. This is true for air source and ground source heat pumps. So Brian's going to talk more about ground source heat pumps, but I just want to flag that there's a rebate for both types of equipment. And again, it's based on the tonnage, which is basically the capacity. It's like the size of the heat pumps. So there's a few different categories based on what you're going to do. The energy optimization rebate is for fully displacing your existing heating and cooling equipment, or integrating it. And then there's another incentive, like if you're just going to do, part of the home and not going to integrate it or not fully displacing what you have. So you get a little bit more money per ton for fully displacing. There's also a tax credit for air source heat pumps. And you can get 30% of the project cost up to $2,000 per year. And so so it's a federal tax credit, and basically it's like off. Assuming if you got the $2,000 tax credit, it would be you just owe $2,000 less in taxes. There is a efficiency criteria for both of those incentives. There's an eligible products list for both things on our website and on the Energy Star website for the tax credit. For ground source heat pumps, I don't know if Brian, you're going to into this, but the tax credit is 30% of the project cost with no cap. So it's a similar design, just without a cap, basically. So I don't have another slide on it. Sorry. Heat pump water heaters. We got a rebate for these. Are effectively a heat pump version of an electric water heater, very energy efficient. I'm going to breeze through some of the details here to save time. There's loan products through Energize Connecticut, so financing options for heat pumps and other energy efficiency improvements. The Smart E-Loan is probably your most common option for that. And we've got a contractor network for heat pumps. So these are the people who are able to use the rebate. We make sure that they're insured, licensed, and trained, but we definitely recommend doing other research on contractors. And we can help you evaluate quotes when you get there to that stage. And so here's the link for the consultations. And again, any of these details, if you have more questions about your home, I'm going to answer anything you want in the chat. But if you have really home-specific questions, we can help you address those in a consultation. I'll put the link for that in the chat so everybody can, just open that on their own and fill out a form. Again, it's no cost, and we'd be happy to help you. And then there's a bunch of other resources on our website. So you can go to energizect.com and find guides and user tips and other resources. Thanks.
Thanks, Matt. I'm jumping in for 1 second. A couple of the participants have told us that they're having trouble with the chat, but that the Q&A tab is working. And we apologize for that. But if you can put your questions in the Q&A tab, and then we will follow up with some of the things that Matt just mentioned in a follow-up email, so you have all those resources.
Awesome. All right, I think it's my turn now. I'm Brian from Dandelion Geothermal. Nice to see everybody. Thanks again to Sustainable Westport for letting me join you guys and chat a little bit about geothermal heat pumps. Kind of how Matt said, like a heat pump is a heat pump. What's the difference between an air source heat pump, which Matt mostly talked about, and a ground source heat pump? Just where we get the heat, right? What is the source of the heat? An air source heat pump is outside getting that heat and effectively the cooling in the summertime with your outside air temperature. A ground source heat pump uses the ground, right? Air source, ground source. That's the big difference as it goes through. And I'm gonna, have a little presentation just to show you guys a little bit of the differences, kind of answer some of the questions you guys might have between those two, and why you might pick one or the other as it goes through. All right, so we'll go through how geothermal works, what an install looks like, because that's a lot of the questions we get. Maybe you've never seen a geothermal install before, and then some of the benefits of geothermal there. Again, I'm with Dandelion. Here's my phone number. My email address will be later if you guys have any questions that you want to follow up with. All right. Awesome. My favorite part is it's a liberation of fossil fuels from your house. So geothermal does represent 100% removal of fossil fuels. So if you have an oil tank, we throw that out for you. If you have a gas line, you don't need it anymore. If you have a propane tank, again, you don't need it anymore. It's 100% solution for your heating and cooling, which is my favorite part here. There's the next slide is just a video, which kind of shows it's like a 30 second or 60 seconds long or so of just an installation, so you kind of can see what it all looks like as it goes through. So, and if the sound doesn't work, just raise your hand and I'll try to figure out what that is, but here we go.
Hi, and welcome to Dandelion. We are excited that you are exploring geothermal for your home. It is the most efficient and sustainable way to heat and cool. This short video will give you an overview of how geothermal heating and cooling works. In a nutshell, this system works by moving heat from the ground into your home in the winter to warm it up, and then moving heat from your home back into the ground in the summer to cool it down. Because the ground remains a constant 55 degrees Fahrenheit year-round, it can both act as a great heat source and also a great heat sink. But before we dive into the details, let's first talk about the major components that make up a geothermal system. There are three of them. First, there's the ground that can go as deep as 500 feet into the ground. This is filled with water mixed with a small amount of earth-friendly antifreeze. Second, there's a geothermal heat pump that replaces your furnace and your air conditioner. This heat pump typically goes in the basement, but it might go in your attic, or in some houses it goes in both places, depending on the setup of the house. Lastly, the system uses ductwork to deliver the heated or cooled air throughout the home. We typically use the ductwork that's already in the house, but some homeowners do need to add ductwork when they get their system installed. Now let's get into a little more detail about how the system works. We'll start with summer, when it's hot outside and you want to keep your house nice and cool. During the summer months, the heat pump takes heat out of the air inside your home and transfers that heat into the water that then circulates through the ground loop. As that now warm water is pumped through the ground loop, it's cooled by the 55-degree ground. In other words, that heat is seeping through the ground loop into the surrounding earth, thereby cooling that water. So now the now colder water can circulate back to the heat pump, and that heat pump is then able to take even more heat out of your house and put that heat into the water, warming it up again. Then, of course, that warmed water is sent back to the ground loop to cool it down. And you can see the cycle continues until the home reaches the desired temperature. One thing about cooling that many people don't realize is that cold is just the absence of heat. So the heat pump isn't really adding cold to your house. It's more like it's removing heat. It's a lot like the way a fridge in your kitchen works. You plug it in, and that fridge will use electricity to cool its inside by pumping heat out into your kitchen. And this makes sense because your fridge is actually a type of heat pump. So now that you understand how your geothermal system does cooling, let's focus on how the geothermal system heats your home. Imagine it's winter and it's really cold outside and you want to keep your house nice and warm. Well, the ground is still 55 degrees. The heat pump pumps water through the ground loops, and that water absorbs heat from the 55-degree ground. This lukewarm water then circulates through the heat pump, which then extracts the heat and concentrates it using what's called a vapor compression refrigeration cycle. I know it sounds complicated, but it's actually the method used in all air conditioners. It allows us to use 55-degree water to produce 100-degree air, which we then can circulate throughout the home until your home reaches the desired temperature. 72 degrees or whatever temperature you've set on the thermostat. The best part of all of this is all you have to do is set the temperature on your thermostat. The system will take care of the rest. Now you are a geothermal expert.
All right, we'll end there.
If you
Sorry, I thought it was longer than 60 seconds. I forgot how long the video was. But anyways, that's basically how geothermal works. Again, it's kind of similar to what Matt was saying. We're going to take heat from the ground, which is at a steady, constant 55 degrees. It's the same in January as in July. It's always 55 degrees or so in Connecticut ground. And we can bring that heat into your house in the wintertime and then move the heat right back down into the ground in the summertime as it goes through. This is what will be buried in the ground. There's nothing sticking out of the ground. Everything's completely buried on the outside with your pipe. And then your heat pump will be down basically exactly where your furnace is right now. So we'll remove your furnace and then throw that out, put in a heat pump, connect to your same existing ductwork, and you're good to go. Your AC unit outside, that also gets to go and gets tossed too, so you don't need that anymore. So I really like that in my house when I got to get rid of my big ugly AC unit outside in the backyard for sure. So that's another big positive in my mind. All right. Here's what the drill rigs look like. So they're Dandelion, we own our own drill rigs. We have it, they're like come on rubber tracks. They're about 6.5 feet wide. So they really can get into lots of different types of backyards. So a lot of the questions we get is, how big is the drill rig? Because my yard is small, etc. So that's where geothermal and residential geothermal is moving towards, is trying to make it more accessible for more homes. Whereas 10 years ago, the drill rigs were enormous and they couldn't fit into most people's residential backyards. Now that the drill rig and the drill rig technologies has gotten better and better, you see more and more geothermal just because now there's more and more houses that can take advantage of what's clearly the best heating and cooling option as it goes through. So that's what the drill rigs look like here. This is what a borehole will look like. So we'll drill down. You'll have pipes, sticking down into the ground after the drill rig's done, and then you come back with an excavator and you dig a trench from where the borehole is. You make a little connection between the horizontal piece and vertical piece. I got my numbers or names mixed up there. And then we dig a trench over towards your the foundation of your house. So this is my front yard here, just to give you an example. It's about a 2-foot deep trench. The pipe is laid in there, and then you pop right through the foundation of your basement to bring the pipes in. If your furnace right now is in your garage or up in your attic space, like there's other solutions for that, but most people's furnaces are in their basement. So just those are what I'll show you pictures of today here. All right. And then afterwards, you fill in the dirt, replant your grass, and unlike solar panels, you never see it ever again. It does make it harder to advertise for geothermal, especially compared to solar. But again, it's a really wonderful thing. This works for retrofits, like existing homes connecting to the ductwork. It's really easy and good for new construction as well, because then obviously you don't have to worry about any grass that you're tearing up as it goes. And that's the basic components of it all, of what we're looking at in terms of heating and cooling on the outside of the house. All right. On the inside of the house, this is what a heat pump would look like. So this would be like a basement version. So looks like a furnace basically, right? It's a metal box, has a fan in it, blows air in through your ductwork. And then the heat exchange and water pump is down here at the bottom. It's called a package unit because it's all in one package. And that's it. That's the only piece of equipment you need. Again, there's nothing outside. There's no other components, just that, and it's connected right to your ductwork. If you have an attic unit, either because you also have one in the basement and in the attic with a bigger house, or maybe you just have one in the attic space, you would have installed what's called a split unit, and half of it would stay down in your basement, connected to the ground loop, so that the water pipe just goes into your basement. And then we put the air handler portion, the fan that blows the air through your ductwork, that portion would go up into the attic space. This is also what you would get if you had just a crawl space. Like if you didn't have enough ceiling height for the package unit, you get a split unit as well. All right. And those are the two types of geothermal heat pumps as it goes through. So you'll get one or both of those in your house. All right. My favorite slide right here, I'm a tree hugging environmentalist. Like this is why I'm doing it. This is why I love my job. I get to help people go from fuel oil, propane, air source heat pumps, natural gas, all the way down this little baby bar right here, right? This is the CO2 impact of your home energy decisions. And the reason for that, right, is because of how much energy you're using and how much energy and smoke and pollution and stuff you're emitting when you do these other options as it goes through. With geothermal, because it's so much more efficient and there's no combustion at all, right? Like there's not even a chimney component with a heat pump. You can just have such a smaller footprint in terms of your carbon emissions at your house. And as you saw on some of Matt's slide, this really kind of directly correlates with costs too, right? Fuel oil is the worst. Propane's a little bit better. Air source heat pumps and natural gas are similar. And then, geothermal is the improvement upon it in terms of your cost output, to heat and cool your house. All right. There's my two cute little kids. I just throw them in there because it's my favorite slide. All right. Just to put some numbers on operating costs, to factor operating costs, it's actually a pretty simple exercise because we know exactly how much heat is in every component, right? We know how much heat is in every gallon of oil, just the chemistry of all the hydrocarbons in the gallon, right? So if we know exactly how many gallons you used, I could tell you exactly how much heat went into your house last year. And then if I know how efficient my heat pump is, which I do, we can tell exactly how many kilowatts you would also use to replace that same amount of heat. Geothermal heat pumps can, again, do that because we have that steady source of ground temperature to work with. So we don't have any variabilities in our capacity or efficiency. Like a geothermal heat pump is always as efficient as it ever will be, right? It doesn't change if it's windy out. It doesn't change if it's too cold out. It's always that same constant, steady, great efficiency. And here's kind of just your comparison, right? Just to throw like easy math numbers on there. Average gallon of oil is about $4. That's, the average price about for the last 12 months. I think Eversource and UI are right around 30 cents a kilowatt. Westport's probably Eversource, right, for the electric provider, I guess. I think that's right. I live in Milford, so I'm on UI, but I think Westport's Eversource. So it's right around 30 cents. This is the equivalent of the amount of heat that 1 gallon of oil produces. Cost you $4 for the oil. It'll cost you just under $4 for the air source heat pump. And it'll cost you $2.19 of electricity for the geothermal heat pump to produce that same amount of heat. So you can take that ratio and multiply it for however many gallons you used last year. This graph over here shows kind of the cost comparison for an average house that burns 1,000 gallons of oil. Right, $4,000 for 4,000 gallons. Sorry, $4,000 for 1,000 gallons. And again, this would be your cost for that same amount of heat for geothermal. Saves you $1,800 for the winter time. And then that same house uses about, we'll say, just over $1,000 to cool that same house. And you get the benefit of cooling with geothermal as well. Because again, we don't have any outdoor compressor units trying to cool your house. Everything is just exchanging heat with that 50-degree earth temperature to cool your house. So you're also going to cut your cooling costs in half in the summertime too. So geothermal offers savings both in the wintertime and the summertime compared to anything else you could ask for. Right. All right. Couple of just like specific, differences between the air source and ground source. Air sources, they have ductless units, which again, Matt talked about kind of like the applications that those make a lot of sense for. There's not really a great ductless option for geothermal. So we only operate with homes with ductwork or can get ductwork as it goes. And some of the other, just differences, just exterior installation, the variable and lower efficiency with the air source heat pumps. I'm a geothermal guy, but I love the idea of not being able to see the things, right? Not having the big compressor outside or any of the wall mounted units as it goes through. And again, with geothermal and ductwork, everything's hidden, which I think is really nice as it goes. So air source heat pumps, there's some great applications for air source heat pumps. I think if you can make geothermal work, like if you have the ductwork, if you have the room for the drill rig, it's a really great option to explore for sure. All right, here's my contact information. And I know that we have hopefully a robust question and answer section later. So I'll pause there and we can go back to Dee Dee or Gretchen to kick that off.
Matt and Brian, thank you so much. Those were great presentations. We are going to get to a question answer period, but first I do want to introduce the participants this evening. We have two residential energy ambassadors. One of them is Scott H. Both of them, I should start by saying, live here in Westport. Scott actually did the air sourced heat pumps. And as he said here, heat pumps are an ideal solution for my home as they are not only saving me money, but also contribute to environmental sustainability. He put in 2 ducted outdoor heat pumps. You can see that's his air handler on the outside. I guess that's what it's called, right? The air handler that's on the outside there. And then he also put in a heat pump water heater, which Matt briefly touched upon. So 4 things Scott wished he knew before initiating the process, as was already touched upon: get a home energy audit and install an extra installation to reduce your required system size and energy usage. If your HVAC contractor does not perform a comprehensive manual J inspection, which is a load calculation that determines the heating and cooling needs of a home, used to size an HVAC system and is required for some permits, find a different contractor. It makes sense to have the size system for the space that you're trying to heat and cool. You don't want something that's too little, but you also don't want something that's too big, because you just don't need it and it's costing you more than you need to spend. Consider location of units based on more operating noise in the winter when heating versus quiet in the summer when cooling, which makes placing further from indoor living space windows ideal because less disruption to outdoor activities in the yard during the summer. Just basically what he's saying, just be conscious of where you're putting the unit. It's going to be a little noisier in the winter and quieter in the summer. So you want to make sure that it's not something that's impeding your peace and quiet. And then solar energy is very beneficial when paired with heat pumps. They make a really good couple. So that's definitely something to consider if you were going to do air source heat pumps, is whether or not you can combine that with solar. Then we have Peter B., also here in Westport, who went the geothermal route. He actually used Dandelion, installed his system in 2024. He has 2 mini splits for non-ducted parts of the house because it's an older home. And he's got a new integrated water heater, and he installed solar in February of 2025. Again, makes for a great combination with the mini splits. So he's got a very, he's got a great system going. He's got the solar, he's got the geothermal, he's got the mini splits. So Peter's top tips: the process takes patience, persistence, and time. Geothermal does require a big dig and disruption. It is going to tear up your yard. There's no question about it. But yards, like, a bad haircut, your hair grows back, so does your yard. The result is quieter than we anticipated. No furnace firing up to boil water or re-engage the air handler, and more constant. We kept our thermostat at 70 all winter, and it was lovely. Basement equipment of pipes and handler takes up less space than furnace and tank, and that is certainly true. They're very compact. So I think we are now on to our question and answer period. I want to thank Scott and Peter for offering to share your experience with our network. If you have questions that you would like them to answer for you, Gretchen, you want to go back one slide? Thank you. You can email them or email info@sustainablewestport.org, and we will put you in touch with either Peter or Steve, depending on who you would like to speak to. And we will also point you in the right direction just in terms of other resources and, however else we can help you guys. So hoping there's now a robust amount of questions. I know there are a few that have already come in. So Gretchen, I'm going to turn it over to you.
Sounds great. And we have some of the questions as well from when you registered. So I'm going to ask the first question from the Q&A tab. I think this is for you, Brian. Brian, your slide showed that the geothermal unit creating hot air goes through air ducts to heat the house. Would it be possible to do the same thing, but create hot water that goes through an existing baseboard system? So
Yeah, it's a really great question. And I'm going to answer it with a sort of. I know that's going to be not what you want to hear, but here's why it's a sort of. Existing baseboard radiators likely are not compatible for geothermal. Existing baseboard radiators, they get their water from a boiler, which boils water. The water is very, very hot. It is much hotter than a geothermal heat pump is designed to get. The geothermal heat pump is designed to get to like 100 degrees. A boiler is putting out, 180-degree water through your radiators. So you probably can't retrofit baseboard radiators to a geothermal system. The other reason why it's usually not done as well is part of the benefits of heat pumps is it does heating and cooling. You can't cool a room through baseboard radiators. So you'd be paying all this money tearing up your backyard for only half of the benefit, really. Now, so that sounded a lot like a no, but I said sort of because you can do, it's called a water-to-water heat pump. And they have these for air source heat pumps too. And it creates hot enough water that if you properly design it, usually it's like a new construction. It's hard to retrofit these types of things. You can have like radiant floor heating. Again, it doesn't do cooling. So sometimes what you do is you do radiant floor heating, maybe for your master bathroom or, maybe the kitchen in the morning or something like that. But then you also have a ducted system to do the heating and the cooling, the main heating, and then obviously all of the cooling. So unfortunately, homes with baseboard heating right now almost certainly need ductwork to make it work for geothermal. And really air source heat pumps, unless you're doing the mini splits as it goes through.
Yeah, I'll just add that there is like some newer equipment coming out that's like getting better at doing heating in cold temperatures using radiant heating. But yeah, like Brian said, in most cases, it's really it's hard to do all of, there's very few homes that are going to be able to do all of their heating with existing radiant American style baseboards,
Yeah.
with air source especially. So.
Yeah, like your existing home, even if you got it to go through the baseboard, you probably have to add more baseboard because all of a sudden your baseboard only has 100-degree water temperature and not 180-degree water temperature, right? Yeah.
Thanks,
More
guys.
common in Europe, the radiant heating there is a lot higher surface area and designed for cooler water temperatures.
Yeah.
One of the participants is concerned that they can't sustain warmth for continuous sub-freezing temperatures like we experienced this year. Please reassure them that if they choose heat pumps for my only source of heating and air conditioning, that I will still be comfortable.
Do you want to?
Yeah,
You can
I'll
go.
take this. So for geothermal specifically, we geothermal heat pumps don't actually care how cold it is outside because we never touch the outside air temperature, right? So it could be negative 20 degrees, but the ground is still 55 degrees. So a geothermal heat pump can really confidently rip out that furnace, rip out that oil tank, and put in a heat pump. And in fact, Connecticut doesn't have this requirement, but New York and Massachusetts, our neighbors, they have a requirement that if you get a geothermal heat pump, in order to get that big check from the state, you have to get rid of your existing heat pump because they are that confident that geothermal is well within its ability to provide all the heat you need. Assuming one of the other points, I think it was Scott in the thing that the manual J is right, that your heat load calculation was properly done. So as long as your contractor did it correctly, yes, there is no concern at all with cold weather.
Yeah, I would say it's a little bit more nuanced for air source, because the performance of the system is affected by the outdoor temperature, which is not, like Brian said, not true for ground source. But yeah, like when it gets colder, air source heat pumps, because they're moving heat from outside, have to work harder, and per BTU, the cost goes up. And some systems, like we looked at earlier, I had that slide up, and some systems lose some of their capacity. So if your goal is to go full heat pump, it totally can do it. There's equipment that's built for it. The sizing just needs to be a little bit more thoughtful than conventional heating equipment, because you're sizing for the heating load and the cooling load. So oversizing the system is going to hurt the performance quite a bit, especially on the cooling side. And because of that other, we just talked about where some systems will lose some of their capacity. But there's data for some systems down to like in the negative 20 degrees. So they measure them at all cold temperatures. And, again, if the manual J, that heat load calculation is done correctly and the selection of the equipment is done correctly, it shouldn't have any issues. And if you want to that's where our consultation service is, I think, a value when you're evaluating quotes. We can help you look at the data and even do the math, compare with calculation, a manual J calculation you get from the contractor, and just help to make sure the system aligns with your goals.
All right, thank you both. A question just came in the Q&A. We all know that heat rises. How efficient are wall-hung or ceiling cassette air source heat pumps versus baseboard or floor mount? Matt, I think maybe that one's for you.
Yeah, it's a good question. The placement of the unit does matter quite a bit. I think the only time, as the commenter is correct, the heat rises, and usually you don't really run into stratification of air in rooms being a problem until you get to like really high ceilings. So if you have a home with higher than normal ceilings, or like a section of the home where like there's open between the first and second floors, then you could definitely run into this like stratification of air there, or like a really high vaulted ceiling. So the placement of the unit matters. The systems, blow air in multiple directions. They've got louvering fins on them that do a good job of like mixing the air in a room. And then the fan, the air is coming out with some velocity as well. So that usually I'll run into that as a large consideration again, unless you're looking at those like larger, rooms with a lot of height to them. So the efficiency is really, I mean, not a large enough difference for it to show up in the data, because they kind of group them. They're the same thing internally. They're just different form factors, I would think about it. So the efficiency isn't very different between different indoor unit styles.
Yeah, I think with most heat pumps, right, you're delivering air, which is going to then circulate through it out, and mix that all up. So you're not, it's not like your toes will be cold and your head will be hot as you're standing there. Like it's just not enough of a height difference. And if you did like Matt said, have a 30-foot family room ceiling, you're probably going to have a ceiling fan on there that's running 365 days a year to bring to circulate the air, and that's all you're trying to do, so that there is no air circulation. But for standard 9-foot ceilings, you're not, I don't think you'd see anything, no matter if it's a wall mount or like all my vents on my second floor, they're all in the ceiling. So and that's a really standard setup for most even ducted homes, to have ductwork up in the ceiling on the second floor.
Yeah, I would say the indoor units are most up to personal preference and where they're able to place them in the room, like if you have the wall room or what. So they do have slight different cost differences though. Like the ceiling units are going to be a little bit more expensive.
So another question that we got: does a heat pump system only use electricity? And if so, what happens when a power outage occurs?
Yeah, exactly right. It does only use electricity. And if the power goes out, your heat pump doesn't work. But what I'll point out with that is your furnace also wouldn't work, nor would your boiler work. So like every heating and cooling system, even if it is oil-based or gas-based or propane-based, the fan that's blowing the air, that's all electric. So every heating and cooling system does need electricity to run. So the way to do that is if you are worried about power outages and stuff, and I know Westport has those, right? Because you have all those beautiful trees and a bunch of old roads as it goes through. You just get a generator if you are worried about it. Heat pumps work on generators. They're hooked up right to your main breaker panel, just like kind of everything else. So you get a generator that would back up your main breaker panel, and be totally fine with that. So yes, it doesn't work without electricity, but also nothing works without electricity as it goes. Yeah, but a good question.
Matt, anything to add to that? I think we covered that one.
Yeah, just that with and Brian, you can fill me in if this is true of ground source heat pumps too, but heat pumps use a lot of electricity. Like most electricity use in a home is heating and cooling, regardless of what you're using, less so with ground source especially. But because of that, and most like portable generators I've heard aren't gonna do a good job of powering a heat pump, for a couple of reasons. So most often you'd be looking at a whole home generator, which are more expensive than a portable generator for sure. But they're also a great like safety measure. And the way I would think about it really is like, where you're located, it's going to be different based on where your home is, right? Like how often do you get power outages and how long do they last? Like where I live, I rarely ever get them, and our power lines are buried in our neighborhood. So like I really almost never have to worry about that. So the risk wouldn't bother me in my situation, but other people might evaluate that differently based on where you're at. So.
Yeah, totally true. Yeah, the portable generators are almost likely not going to be big enough to support any type of heat pump. Yeah.
Yeah.
Or air conditioner for that matter, right? Like it's
Mm-hmm.
I have one more question to ask. Can you switch out basically one appliance at a time? Could you, for example, first do your hot water heater, then your air conditioning, then your furnace, or is that not possible?
Yeah, you can go ahead, Matt.
It totally is. Yeah. Yeah, no, and if your goal is to like fully decarbonize your home, totally, do things at the pace that makes sense. I think my advice is always replace things at the time they need to be replaced is going to be when you get the best value. So like we looked at earlier, some cost comparisons, and particularly with air source, like unless you're switching from electric resistance heat, like electric baseboard, you're saving a little bit of money potentially, but not enough to pay off the cost of the system, right? So it's a great thing to consider when the time comes. And but I think there's a logical time to do a lot of upgrades. And you know if you're really motivated and your main motivation is carbon emissions, like, and you want to do it sooner than later, go ahead and do it all at once. But really the timing's up to you. And just to say, like, in our consultations, we can talk about more than heat pumps. So if you want to take the time to put together like a little roadmap for your decarbonization goals, like we can do that, with our heat pump consultations. We don't, they're called, in a different context, I might call them a decarbonization consultation. So we can definitely talk about more than just heat pumps.
And I'll add that there's lots of things that like burn stuff at your house, right? There's the stove, water, your heat. So like those are basically your three main things. So those three can happen at any time. What I will just a clarification is you wouldn't get a heat pump if like you only wanted a new cooling unit, because you would also be replacing your furnace too, right? Like, so your heating and cooling sort of happen at the same time. Unless, well, I guess, if you're doing a hybrid, like Matt talked about, like you could keep your heater and then just do cooling, or vice versa. But generally people are doing the heating and cooling, right? HVAC is like that system. And in geothermal, again, because it's 100% replacement, like your AC gets thrown out, your furnace gets thrown out. Like there is no like keeping one or the other when you do geothermal. So, but your water heater, yeah, do that next year or do that before we come. That's totally fine. It's not connected in any way to geothermal, and then same with your stove and things like that too. Yeah.
Can you do water heating with off the geo loop though? Off of the is that
Yeah.
true?
So that's one of those, like, I'll say sort of again, unfortunately, right? Yes, technically, yes. It's called a de-superheater, and it's a standalone tank that collects a little bit of the extra heat, especially in the summertime. Instead of taking all that heat from your house and dumping it into the ground, you take a little bit of that heat and you preheat some water in a big, like 80-gallon tank that just sits there. It's not even connected to electricity. It's just sitting there. And then now that preheated water is then pumped to your other water heater, your existing water heater or your new water heater. And then now that water heater, instead of getting 40-degree tap water from the street, or your well, gets 80-degree water or so. So it makes your existing water heater slightly more efficient. We used to install a bunch of them. We've installed hundreds of them. They used to be part of our standard package because they sound cool and they're a fun thing to say, de-superheater. But we just did the math, and they just weren't saving enough energy in New England to make it worth it, because our summers just aren't hot enough or long enough, and that's when you get the most benefit from those, is when you're dumping extra heat out of your house. So we scratched it. It cost us like $2,000 to put in, and it was saving people $50 a year, and that's just bad math. So like, yes, technically geothermal can provide some supplemental heat, never your whole heat for your hot water, but some supplemental hot water. But in New England, it's just not really worth it, is what we found. Down in Florida, where they're cranking their AC all year round, like, yeah, probably that does make sense. But yeah, not up here is what we found.
Thanks. Sorry to throw that one in.
No, that's fine. I used to love selling DC superheaters. It was really fun.
Well, that's all the questions I have. Dee Dee, can I pass it back to you?
Sure. So we would love to have you join Sustainable Westport. And right now we're doing a thing called Make a Promise for the Planet. So if you go onto our website, the question is, what do you promise to do for the planet? And a couple of the answers are, I promise to continue to promote renewable energy and to help others to switch to solar for their energy needs. That comes from one of our local architects, John Roundtree. Karen R., I promise to choose fruits and vegetables sold without plastic packaging and not bag produce that I buy. I promise to stop using paper napkins and only use cloth. There's a gazillion things. So take a minute, just think about what you might promise to do for the planet, and then visit sustainablewestport.org to make your promise today. So thank you guys so much for joining us. Gretchen, if you wouldn't mind just throwing up the slide again that has the website, which is info@sustainablewestport.org, I think. Yes, thank you. So again, if you guys have any more questions, if you want to ask our residential energy ambassadors any questions, please send us an email at info@sustainablewestport.org. Again, thank you to our residential, Scott and Peter, and to Matt and Brian. You guys were awesome. And I hope you all enjoyed the evening and that you learned something.